This is the second problem that we had for optimization off of the review sheet. And it was a box with a square base and open top must have a volume of 32,000 cubic centimeters, and we were supposed to find the dimensions of the box that minimized the amount of material used. Okay, so first off, just to kind of get a little idea of where we're going and what we're trying to do. Here's a box and the top is open, and it said that it had a square base. So I'm just going to say X is the base, and so a square, all sides are equal, so X and X, so now we have a square base. Alright, well, the height, it didn't give us a height, so we're just going to say Y. Okay, and we have four sides, so we have our bottom, and as far as area goes, you just take one side and multiply it by one side and the bottom, or one side and the top, whatever. Well, since our base is square, the area for our bottom is just going to be X squared, and the area for one of our sides is just going to be X and Y. But if you notice, we actually have four sides, 1, 2, 3, and 4, so that's going to be 4XY, because we have four sides. So our area total is going to be X squared plus 4XY. Okay, so that part wasn't too bad. And so reading the problem again, it said that our volume of the box must be 32,000 cubic centimeters. Well, volume is basically length times your width times your height. Well, the length is going to be X, the width is going to be X, and our height is going to be our Y. So we have volume is equal to X squared Y, and it said that that had to be equal to 32,000 cubic centimeters. Okay, so we want to try to get rid of one of those variables. So to do that, just divide by X squared, and we get Y is equal to 32,000 over X squared. Alright, so there's a pretty good starting point for us. Okay, so if you remember, we came up with a little formula for our total area as being X squared plus 4XY, and whenever we messed with the volume, we came up with our Y being equal to 32,000 over X squared. So now, we're trying to eliminate one of the variables, just plug that Y in right there. So now our equation for our area looks like X squared plus 4X times Y, which is 32,000 divided by X squared. So if you want, you can just bring that on over. And so basically, one of these x's will cancel with that one. And so we can simplify that down to x squared plus 128,000 over x. Okay, so now we need to take the derivative of that. It's going to be equal to 2x plus, we have a quotient rule, so that's going to be the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom, which is just 1, all over the bottom squared. Okay, so after we clean that up, that's what that looks like. And you can see we have an x squared on the bottom right here. So to get rid of that, we can just multiply through by x squared, and that'll hit both of our terms. And so that will come out to 2x cubed minus 128 minus 128,000. So then we set that equal to 0, so we get 128,000 is equal to 2x cubed divided by 2, and we get 64,000 is equal to x cubed. So then we just take the cubed root of each side, and then we're left with x is equal to the cubed root, 64,000. And so whenever we do that, we come out with 40. And if you remember, we've been dealing with volume the whole time. And so the units for the 64,000 is still centimeters cubed. Well, whenever you take the cubed root, the centimeters, that's actually going to cancel out. And so we come out with our x being 40 centimeters. Okay, so going back to our derivative, to find out if it's like a min, like if the area is a minimum, we need to take the second derivative. And whenever you do that, that's going to come out to 2 minus, you're going to have another quotient rule, which is the bottom times the derivative of the top, which is going to be 0, minus the top times the derivative of the bottom, which is 2x. And now that's going to be over the bottom squared, which is x to the 4th. Okay, so whenever you clean that up, you're going to have 2 minus a negative 128,000 times 2x over x to the fourth. So one of those x's will cancel right there, and so then you come up with 2 minus a negative is going to give you a positive. 128,000 times 2 is going to give you 256,000 over x cubed. As you can see, that is positive, and whenever f double prime is greater than 0, you do in fact have a min. Okay, so we know that checks out. And if you remember, whenever we found our x to be 40 centimeters, we just go ahead and plug that back in to our y to find out what our y was. And if you remember, the y was 32,000 centimeters cubed, and that was going to be over x squared. Well, our x squared is 40 centimeters, so we can go ahead and plug that in, 32,000 centimeters cubed divided by 40 centimeters squared. Okay, and whenever we do that, we're going to come out with 32,000 centimeters cubed over 1,600 centimeters squared. Those units are going to cancel, and we're going to be left with 1 centimeter up top. And then 1,600 goes into 32,000 20 times. So our y comes out to 20 centimeters. So we have just found the dimensions that it was asking for back in the problem for the box.